Hi friends, this is KM with Prashant, and today we can learn the largest common substring problem. Given two strings, and our aim is to find the largest common substring among these strings. So coming to the first method, simply compare each element in the string 1 with each element in the string 2. Comparing C with B, this is not equal. Comparing C with Z, not equal. A not equal. C, Y, A, and C, it is equal. Now run a sub loop that iterates until these two strings are equal. And now this is not equal. Now the largest common substring which we had found up to now is CA, which length is 2, and the position of this string is current index minus length, that is 5, and the length is 2. Make an entry of this index and the position in the table and update the max length to 2. Next, continue iteration. So C not equal to A, C not equal to F, R, D, B. Now this is the important step. Here we have found a common substring with the length 2. We need not consider any substring which is length of 1 or else which is less than the max length, because our aim is to find the largest common substring. So we need not consider any substring that enters which has length less than the max length. So for example, if we consider a common substring B, C, D, if we got like this, then we need not consider any substring later B, C, C, D, D, B, because this length is less than this. Our aim is to find the largest common substring, right? So we need not consider the strings which has the length less than the maximum length. That's the reason. So stop the inner for loop at string length minus the max length. So we can eliminate checking the strings which has length 1. So update the outer for loop. Continue the iteration. Now A compare with B, and now A equal, but the length is 1, so which is less than the max length, so we need not to consider that. Length 1, and update the outer for loop again, and here the length is 1, you need not consider it. Similarly B, Z, A, and Y, whose length is greater than the max length, so update the max length and make this entry in the table. The position is the current position minus length. Current position is 4 minus the length is 4. So 4 minus 4 is 0. The length is 4 and the position is 0. 0, 4. This means the common largest substring starts at the position 0 and its length is 4. And continue iterating. C, D, B. So observe here, now as the max length is increased, we just iterate to string length minus the max length, because we can eliminate the strings which has length less than the max length. So eliminating the strings which has length less than 4, we can iterate only up to string length minus max length in the second string. So continue and iteration, which is less than this common substring is less than the max length, so leave it. Now observe this. In the main string also we are iterating up to string length minus the max length, because here also eliminating the checking for the string which has the length less than the max length. So all the strings having the length less than the max length are not considered here, or all neglected. Now we will stop here, and now we will check the table here. And in the table max length we have position 0 and the length is 4. So go to position 0 and length 4. BZAY is the common largest substring of the two strings. So let's see another example. If we given a larger strings like this, and there is only one difference, the last character B and C. So for this, if we see if we apply the same thing here, what happened means select an index and iterate through all the indices, they're equal, and the maximum length will be So the maximal length will be n minus 1, and the position will be 0. And next time we will iterate up to only string length minus max length, that is only 1. So we can directly walk to the array to the end and we will get the. Now let us learn the method 2 for largest common substring problem. Consider the two strings vertical and horizontally, and consider a matrix here. All the cells in the matrix are initialized to 0. Repeating, all the cells in the matrix are initialized to 0. Now compare the first element with every element of the second string, comparing z with h, and z is equal to z. So initialize this to 1, and the common largest substring which you have found is a max of 1, and its position is 0, length is 1. And coming to the next element, compare a with every element of the second string. Comparing every element, a compared to a will get here too. Let's put this. See this code. If I equal to 0 or j equal to 0, which means if it is a first column or if it is a first row, then it will not have a upper diagonal element. Thus directly assign value 1 for that. If the element has upper diagonal value, then the value that must be entered in the cell must be equal to 1 plus the value in the upper diagonal cell. So set of ij equal to set of I minus 1 plus set of j minus 1 plus 1, and it is 2. So the common largest substring length which we have found is 2, and its position is I minus max plus 1. I is 1, max 2 plus 1, it is 0. It starts from 0 and max length is 2, which means ZA is the common largest substring which we have found up to now. And A is equal to A, but the upper diagonal element is 0, so it is 1. So coming to next, comparing A with every element in the second string. Now A is equal to A, but the upper diagonal element is 0. And next, A is equal to A, upper diagonal element is 2, 2 plus 1, it is 3. So it is greater than the max which you had stored earlier. So update the position equal to I minus max plus 1, that is 0, and max length is 3. And going further, comparing h with every element in the second string, it is 1, 1, 1, as the upper diagonal element is 0, and here 1, and it is 2 as the upper diagonal element is 1, here 2, and next 1, 2, and 3. This is the new entry. So make this entry position equal to I minus max plus 1 and 5 minus 3 plus 1, that equal to 3. And going further, comparing D with every element in the second string, these two are again new entries, 1, 1, and comparing T, it is 2, 1 plus 1. And here comparing D with D, this is new entry, the upper diagonal is 0, and D with D, upper diagonal is 2, 2 plus 1, 3. And now as we have reached the end, see what are the common substring. The largest max length is 3, and the common substrings with the length 3 are these 3 elements. So let's see the table which we have entered until now. So max length is 3 and the positions are 0, 3 and 6. So from the 0th position, length 3, ZAA is one of the common largest substrings, ZAA, and position 3, 0, 1, 2, 3 from H, the length is 3, H is the second largest common substring, and similarly DT is the common largest substring. Using this matrix we can find the common largest substring. Thank you for watching my video.